Here in the vast, lush fields of Trinity Western University, we are in search of the forces at play that influence the abundant growth of this landscape. You may have heard of the man responsible for this environment's growth, but never before has his experience been documented on camera. Our film crew has been given a rare opportunity to investigate his experiences and learn of the ways that one farmer has utilized modern science to revolutionize his practices.
Good morning, I'm Farmer Durbar, and today we will be discussing nanotechnology in biogas and agriculture as implemented on my farm.
To learn about the technologies that Farmer Durbach uses, we consulted our resident scientist, Dr. Ross, to give us insight into his practices.
Hello there, I'm Bob Ross, and I am a professor here in chemistry, paintology, and nanotechnology. So it's interesting to see what Farmer Durbach is doing on his farm, including all that nanotechnology in biogas production and in agriculture. It's quite fascinating.
Dr. Ross studied nanotechnology at Trinity Western University for nearly 3 months.
It comes as no surprise that with an increasing population, there comes a cost to the depleting resources of the world. An increasing population no doubt puts a strain on the resources and the economy and the ecology and the global health. Farmer Durbach has found a way, though, to incorporate nanotechnology into producing an alternate fuel source, biogas. And so biogas is very interesting as it is produced from organic matter, fecal matter, manure, and traditionally it's digested using bacteria. And this is what's been done traditionally throughout history before fossil fuels became streamlined. Now it appears that Farmer Durbach is using this nanotechnology to produce biogas on his farm. It's pretty fascinating.
During my time on my farm, I've been experimenting with different types of nanomaterials to help catalyze and streamline the use of biogas in alternative fuel sources. For instance, I've been experimenting with carbon-based nanoparticles such as graphene, metal oxides, metallic nanoparticles on organic substrates commonly found around farm pastures like mine, including cow dung. And from that, it increases the anaerobic digestion of materials in the substrate to produce excess amounts of methane, which can be captured and repurposed as biogas.
Farmer Durbach was hesitant to share his personal techniques in the production of biogas on his farm. However, our highly educated crew was able to make some predictions about his methods.
So this here are the figures showing the various nanomaterials and percentages used in anaerobic digestion. So the most popular nanomaterial that is used in anaerobic digestion is metallic nanoparticles, and these include nickel, cobalt, nano-zero valent iron, cadmium and zinc, etc. There's many more. These metallic nanoparticles are thought to play a role in reducing the lag time of increasing methane gas production. And when I say lag time, I am speaking to the time it takes for bacteria to get settled and ready to reproduce and to produce, multiply basically. And so once that lag time is overcome, it will see the population of the bacterial colonies skyrocketing. And as the bacteria increase in numbers, then so can the production of anaerobic digestion and the production of biogas. And therefore, the metallic nanoparticles can be seen as initiators, inhibitors, enzyme co-activators, and so on within the bacteria colonies. The second most popular nanomaterial is metal oxides, so zinc oxide, copper oxide, titanium oxide, etc. So, I'm going to give you a visual representation of how nanoparticles actually enhance biogas production. So we have a chart. Alright, so I'm going to draw the graph better here. Right, so biogas production, when it gets produced by the use of iron oxide, when iron oxide is present in the organic matter, we see that the biogas production, milliliters, goes up exponentially over time. Without the nanoparticles, we see that the biogas production is very much more gradual.
Dr. Ross was kind enough to send us this image from a recent publication, and indeed, these are the trends we see when iron oxide nanoparticles are added.
The other two nanomaterials that are also used in this process can be carbon-based nanomaterials, graphene, activated carbon, biochars. And lastly, we have nanocomposite materials such as NZVI zeolites and zinc ferrous carbon nanomaterials.
Now, we asked Dr. Ross to expand on what he meant by NZVI nanocomposite materials and their relationship with biogas production.
When I say NZVI, I am referring to nanoscaled zero-valent iron. Zero-valent iron is an inexpensive, non-toxic, and moderate reducing agent. This, in the nanoscale, has been known to promote soil remediation, and this has also been known to accelerate sludge stabilization in anaerobic digestion, resulting in increased biogas and methane production. Now, nanomaterials like zero-valent iron are known to release electrons in the process of methanogenesis, resulting in increased methane production. And when I say methanogenesis, this is the process that generates methane as the final product of metabolism from the organic waste, in which carbon dioxide is reduced to methane and the hydrogen is oxidized to the H+ ion and eventually to form water. Electrons aid in this process, and that is coming from zero-valent iron. Now, Durbox is an incredibly smart man. Once he developed nanomaterials and realized their large array of applications, beyond just biogas, he started using them in everything, even agriculture.
I have been using a rather green chemistry approach that makes use of antimicrobial or pesticide-like properties.
What Farmer Durbach is most likely doing is using nanomaterials to encapsulate and deliver pesticidal active ingredients in a responsive manner that allows for an increase in pesticidal efficacy and efficiency. Scientists have actually come to call these materials as nanocides, and they are water-soluble unlike the conventional hydrophobic pesticides and are capable of eliminating the use of toxic organic solvents.
Nanotechnology.
What Durbach is doing, I sincerely believe, is literally outstanding in his field.
Farmer Durbach's innovative use of nanotechnology in his farming practices has clearly been beneficial. Although he has seen individual success, how impactful will nanotechnology be in the economic sectors of agriculture and biogas? We asked an economist to help us explore these answers.
Hi, I'm Stella. I'm economist and I'm from Trinity Western University of Business. The global agricultural nanotechnology market size is valued at $321.13 billion in 2022 and is predicted to reach $868.98 billion by the year of 2031. Here is the Global Agricultural Nanotechnology Market Research Report by 2023 this year, and here is the market size of the nanotechnology.
We can see that the compound annual growth rate, abbreviated CAGR, is expected to grow 11.94% over the forecast period, reaching an estimated $869 billion in value by 2031. Farmers will likely be the primary users of this technology, meaning that Farmer Durbach's success is an excellent indication of future growth trends. Specifically, these will be in the fields of nanoherbicides and fertilizers, as discussed by Dr. Ross.
This may cause growing development in the farming industry in nations like United States and Canada. Same as nanotechnology market on biogas, we can see about 4.3% market growth rate in the next 8 years. The economic evaluation confirmed that applying nanotechnology in anaerobic digestion by using iron nanoparticles could save 272,000 USD per year and cut down to carbon dioxide emissions by 1,660 tons per year compared to the traditional process. However, global agricultural nanotechnology market growth also is limited by factors such as lack of knowledge and education among farmers.
It is my belief as a Christian that we should use nanotechnology in agriculture and biofuels, as it is a great resource to practice stewardship of God's earth as children of God.
Here we have explored the ways that nanotechnology has revolutionized the sectors of agriculture and biogas. Farmer Durbach has given insight into the ways that he has incorporated this technology into his farming practices. Through the careful analysis of Dr. Ross and Stella, we now have a greater understanding of the function of these technologies and their impacts on the North American economy. In comparison to other farming practices, it's important to remember that the little things can make a large difference.